Hello guys, welcome to SSC JEE CBT 2 2025 Electrical Practice Questions. So will be a daily dose series and we will practice as many MCQs as possible before the CBT 2 exam so that by the time of exam we will be ready and we can crack the exam. So let's go to the first question. You can see what is the coupling factor between the two coils each having a self-inductance of 25 millihenries and the mutual inductance is 25 millihenries. So first let us write down the given data in this question. Okay. So what they have given is self-inductance of the first and second coils are equal and they are 25 millihenries. Okay. And the mutual inductance given is also 25 millihenries. And what they have asked is coupling factor. Okay, we have to find the coupling factor in this scenario. So we all know the formula that mutual inductance M is equal to coupling factor times under root of L1 L2. So if we rewrite this formula, we'll get K equal to M by under root of L1 L2. So we will get what is the mutual inductance? 25 millihenries. So all are in millihenries, we can neglect that, and under root of 25 times 25. So this will get cancelled with the root and it will be 25 divided by 25. So 1 1. So coupling factor is equal to 1. So what is the right option? Option C is the correct answer. So let's go to the next question. Here they have given they are asking the equivalent inductance between the terminals 1 and 2. So you can see there is a star connection here. So it is difficult to simplify the circuit without converting it into delta. So we all know whenever you convert star to delta, when all these three 1 henries, 1 henries and 1 henries, so it will be multiplied by 3 times. Okay, so let's draw the equivalent circuit. 3 henries, so the circuit will look like this. So after converting the star to delta, it will look like this. This is 3 henries, 3 henries, 3 henries, and this is 3 henries, 3 henries, 3 henries. So these are in parallel, these are in parallel, these are in parallel. So R1 R2 by R1 plus R2. As R1 and R2 are equal, the equivalent resistance is R by 2. So we'll get an equivalent circuit of so 1.5 henries. 3 by 2 is equal to 1.5, 1.5 henries, 1.5 henries. So which will become like this. So 1.5 plus these two are in series. So 1.5 plus 1.5 equal to 3 henries, 1.5 henries. So these two are in parallel. So equivalent inductance is equal to 1.5 into 3 by 1.5 plus 3 equal to 4.5 divided by 4.5, which is equal to 1. The correct option for this question is option D. Okay, let's go to the next question. So here you can see they have given two lists, list 1 and list 2. We have to match with the corresponding Q factors. So option A is what? It is a series RL circuit. Therefore Q factor will become XL by R. X equal to omega L by R. Therefore, what is the correct match for the option A? It is 1. So 1. Then B. It is a series RC circuit. Q factor equal to XC by R. What is XC? 1 by omega C. So it will become 1 by omega RC. What is the correct match for the option 2? 1 by omega RC. That would be option 4. So the match for option B is option 4. Okay. Then C. It is a parallel RL circuit. Q factor equal to formula. This changes here. The R and X are reversed. So it will become R by XL, which is equal to R by omega L. So which will match that third one in the list 2. So C is matched with 3. Now D. Parallel RC circuit. Q factor equal to R by XC, which is equal to R by 1 by omega C equal to omega RC. What matches the second one? So the correct match is 2. So in this way we will match the least one with the least 2. Next question. The Thevenin's resistance of some network is negative, which indicates. So they have given a Thevenin's resistance of some network and which is RTH. It is found that its value is negative. What does it indicate? It indicates that the presence of dependent sources in that network. So option C is the correct answer. Okay. Here you can see the question has given the Q factor of a series RLC circuit is 5. Its resonance frequency is 1 kilohertz and the power consumption, that is power dissipation, is 250 watts and it takes a current of 1 amperes. What is the inductance of the circuit? We have to find the inductance. So as per the given data, power is equal to 250 watts. So let's assume we know that inductor L and C do not consume power. Only R is the one consuming the power. So power dissipation is equal to I square R. From this we can find the R is equal to power by I square, which is equal to 250 watts and the current is 1 amperes. So the resistance is 250 ohms. Okay. We know the formula for Q factor. Q factor is equal to XL by R, as it is a series network. X equal to omega L by R. We know omega equal to 2 pi F L by R. So Q factor. So what we have to find? L. L equal to Q factor into R divided by 2 pi F. Now we will substitute the values. What is the Q factor given? It is the 5 into resistance of the circuit is 250 ohms divided by 2 pi into what is the resonance frequency? 1 kilohertz. They have given it in the question itself, 10 to the power of 3. After solving this, we will get the equivalent inductance of L equivalent is equal to 0.2 henries. So what is the correct answer for this question is option A. Let's go to the next question. They have given the VI characteristics of a circuit, okay, and it consists of a linear resistor and independent sources. So if a capacitor of 4 microfarad, so this is 4 microfarad, not millifarad, is connected across the terminal AB, the time constant of the system. So if we connect a capacitor of 4 microfarad, what is the time constant? So from this VI characteristics, we can find the resistance of the circuit R is equal to VOC by ISC, which is 10 volts divided by 2 milliamps, 10 to the power of minus 3, which is equal to 5 kilo ohms. Okay, I have found the resistance. So what they have said is that if you add a capacitor along the terminals AB, what is the time constant? So we all know the time constant is equal to RC. We know the value of R and we know the value of C. 5 kilo ohms into capacitance is equal to 4 microfarad into 10 to the power of minus 6. So this will get cancelled, this will get minus 3. So 5 4s are 20 milliseconds is the correct answer. So the right option for this question is option A. Okay. So let's go to the next question. Consider the circuit shown in figure below. At steady state, the energy stored in the inductor is 32. So we have to find the resistance value of resistor in ohm. So these resistance we have to find. So we know that energy stored in an inductor E equal to half Li square, right? So from this we can substitute the values. 32 joules of energy stored, so half into L, inductance is 4, into I square, we don't know the value of current. So 2 ones are 2 twos are 2 ones are 2 16s are 32. So I square is equal to 32, which implies I equal to sorry this is 16. So I equal to under root of 16, I equal to 4 amperes. Okay, so the current flowing here is I load equal to 4 amps. So from the current division rule, we know that IL equal to total current I into opposite resistance of opposite branch, that is 60 ohms. 60 divided by total resistance of the cell, 60 plus R. So if we substitute the values, we will get the value of R. So 4 amperes equal to I into 60. So I, what is the total current? It is 8. So 8 amperes into 60 by 60 plus R. 4 ones are 4 twos are. So 60 plus R equal to 260s are 120, which means R equal to 120 minus 60, R equal to 60 ohms is the correct answer. So what is the correct option for this question is option D is the correct answer. So let's go to the next question. For the circuit shown below, the voltage across 40 microfarads capacitor is dash volts. So what is the voltage across these capacitor? We can just simply find the equivalent capacitance of this parallel circuit. So yeah, we can easily get the voltage. So what is the C equivalent of these two capacitors? So capacitors connected in series is something equivalent to resistors connected in parallel. So R1 R2 by R1 plus R2. So C1 60 microfarads into 30 by 60 plus 30, which is equal to 60 into 30 by 90. 1 za 3 za 1 za 2 za, which is equal to 20 microfarads. So these 20 microfarads will be in parallel with 20 microfarads. So capacitors in parallel, the equivalent capacitance will become arithmetic sum. Therefore this circuit would look something like this: 40 microfarads, 20, here 20 microfarad. Okay, so equivalent is 40 microfarads plus 20 plus 20, 40 microfarads. Here the voltage connected is 90 volts. So as per the KVL, Kirchhoff's voltage law, here 45 volts will be dropped and here 45 volts will be dropped, because both capacitances are same. So the correct option for this question is D. Okay, let's go to the next question. Here they have given a circuit, right, and they have asked the value of load impedance for which it will draw a maximum power. So according to maximum power transfer theorem, the impedance of load should be equal to internal impedance of the circuit, which is Thevenin's equivalent impedance. So to find the Thevenin's equivalent, you can see it is simple, because you can short circuit the voltage sources and open circuit the current sources and look the equivalent resistance from the load terminals. So that is Thevenin's equivalent. But you can see it is difficult, because here it is delta connected, these three, and both are equal in magnitude. So simply we have to convert from delta to star. So it will be divided by 3 times. So we will get an equivalent circuit something like this: star connection, this is the ZTH, and this is 10 ohms. This is short circuited, which means this terminal and this terminal is short circuited. So this is 12 by 3 equal to J4. So J4, this is J4, J4, 10 ohms. So the ZTH, Thevenin's equivalent impedance, is equal to 4 ohms J4 plus, these two are in series, that is J4 plus 10. This is parallel with J4, this one. So simply you can write this like this. So in parallel with J4. So J4 plus J4 plus 10 into J4 divided by j4 plus 10 plus j4. If you simplify this, we will get the equivalent ZTH is equal to 0.975 minus J 7.21 ohms. So option B is the correct answer. Okay. So let's go to the next question. Here you can see we have to find the equivalent resistance R between the terminals A and B. So here you can see it is a delta network. All of the ohms resistors are connected in delta and all of them are equal in magnitude, which means for delta to star conversion it will be divided by 3 times. So the equivalent resistance circuit would become something like this. So 3 by 3 equal to 1 ohms. So 1 ohms, 1 ohms, 1 ohms, 8 ohms, 6 ohms, 2 ohms. So these are in series, these are in series. So it will become something like this: 6 ohms, 1 ohms, 9 ohms, 3 ohms. So these are in parallel. So 3 nines are by 3 plus 9 equal to 12. So 3 ones are 4s are equal to 9 by 4 equal to 2.25 ohms. So the circuit would look something like this: 6 ohms, 1 ohm, 2.25 ohms. So 6 ohms in parallel with 1 plus 2.25 ohms, which is equal to 6 in parallel with 3.25. 6 into 3.25 by 6 plus 3.25. So which is equal to 2.10 ohms. So what is the correct option for this question? Option A is the correct answer. So that's it guys, that's it for today. Thank you for watching. If you want the PDF of this class, you will get it in the description box below. It will be uploaded in my Telegram channel. So please like and subscribe to the channel. Thank you for watching.